Assalamu alaikum, ladies and gentlemen. This is Adnan Kazi, and today we will be talking about data platforms. If you are a student and want to build a career in data engineering, or you are working in a company that provides data platforms, data engineering solutions to customers across the globe, I think this video is going to be very useful for you. So first of all, what you need to understand is that decades ago, people were still using data to understand how businesses are performing. They wanted to convert data into insights for their business decisions, etc., so that they can make informed decisions. And they were doing it pretty fine, but there were problems, right? So initially what happened was they used to have one server, one machine. It could be a desktop machine. It could be a simple, computer system with some hard drives, RAM, CPU, etc. And they used to put data in it and they started analyzing. They used to draw graphs. They used to create insights, understand, identify patterns, and look at the data, eyeball the data, and see what's making sense and what's not making sense for the businesses, right? Well, the problem was that when the data, needs increased, they wanted more storage, more RAM, more power, more, insights to be generated from the computer systems. So they decided that we need to do something more. And that's why, all these big players like Teradata and Oracle came into the scene where Teradata came with this a good solution to this problem, and they said, we're going to be building a massively parallel processing database, which means that there's not going to be only one server now. There are going to be multiple servers working in parallel. So when you're trying to analyze data and run queries, your data will be divided and spread across different nodes or servers, and then we are going to be running things in parallel and then consolidating the answers and presenting to the users in one go, helping the time to analysis accelerate, right? But there's again a problem even with this as well, because these systems like Teradata, although they were doing pretty well, they were only doing the structured data analysis, which means they were based on tabular data, relational database management systems, which mean rows and columns. So it was very tightly coupled, very well organized, structured data. But people wanted more data to analyze more complex problems within their businesses. So they wanted ATM logs, they wanted contact center logs, they wanted CCTV videos, they wanted YouTube videos, Twitter data, social media, etc. And that is what changed in 2007. And that is where the idea of Hadoop system came in, where they said that there are two types of data now. One is a structured data, which is a small data, not really small, but still let's call it small data just for the sake of it. And then there's big data. Big data is all these logs, ledgers, ATM logs, CCTV videos, YouTube videos, social media, Twitter, etc. So in order for you to analyze these big data sets, you wanted something more powerful, more well distributed, etc., and more parallel. And that is where the idea of Hadoop came in. And what Hadoop did was they said, okay, we'll also do multiple, distributed computing. So multiple systems, multiple servers, like hundreds of servers running in parallel. But again, but they were primarily built for large storage systems like videos, unstructured data, semi-structured data, logs, etc. Big data, as the name suggests. The problem with the big data still was, and now there are two systems. One is for structured, which is data warehouse built on Teradata or other data platforms, and one is Hadoop, which is for big data only. And they did try to use Hadoop for some relational kind of workloads as well, but that was not easy. The Hadoop was not meant for that, right? But still, Hadoop was creating a problem because, yes, it's distributed systems, there's a lot of parallelism, but the data retrieval was being done through hard drives. And hard drive-based data retrieval is slow, basically. So when the data size increased, they started struggling with that as well. So now a bunch of researchers from one of the universities in the US, they came up and solved this problem. They said, okay, we're going to try to use Hadoop, but we're going to do in-memory analytics based on Hadoop. So they wanted to replace hard drives with RAM in each of the distributed systems, nodes or servers within the Hadoop cluster. And they said, okay, now the query retrieval will be very fast as compared to the hard drive's time. So now most of the data will be in RAM that is needed, that is the hot data. And so you get more quick answers to your business questions so that you can make informed decisions timely. So this is great. So now Hadoop data warehouse is running for structured data analysis. It's costly storage, but at the same time, you have a cheap storage in the form of Hadoop. And now the hard drive problem has been resolved. Slowness has gone down. Map reduce being done on RAM, which means this is great. Everything is in parallel and you're getting quick answers to your queries. But the problem was that this is based on data engineering. So you're building pipelines, you're preparing data for analysis, etc. But in 2008, 2009, everybody started talking about data sciences, machine learning, and they wanted to run machine learning models and data science models on this big data as well, not only on the structured data. So what happened was that, for these this Spark system, which I said, the RAM based Hadoop, built by some researchers in one of the universities in the US. Sorry, I forgot to tell the name. The name of the system was Spark. Basically, it's Hadoop on steroids, basically, based on the RAM's intervention. So the problem with that was that that was not currently allowing, data science to do Python on Spark, because data science people loved Python for their machine learning models, data wrangling, etc. While Spark allowed, Java and Scala based, interaction with the system. So then they built PySpark, which means that now data scientists can use Python to actually do, run read their models and, getting the benefits of parallelism that Hadoop brings or Spark brings, right? So this problem was solved as well. So now we have integration of data engineers and data scientists all in one, which is one platform, which is Spark, using PySpark and the features of Hadoop, and everything in RAM and parallel. But still, there are two systems. One is data warehouse, one is data lake, and they have different workloads, they have different properties, they have different traits and purposes. So what happened was that Databricks came into play now and said, okay, why do we need to have two systems in place? Why can't we just bring in data warehouse into the data lake and come up with something known as data lakehouse? And that's exactly what they did, and they did it brilliantly, to be honest. So now we have Databricks, and what it does effectively is it combines all the workloads into one platform. Your structured data, your semi-structured data, your unstructured data is residing in one platform. You don't need to move data outside of one system to promote it to a data warehouse or demote it from a data warehouse to a data lake, etc., based on different workloads and query requirements of the business users. You actually have one system where everything is consolidated in one way, and all data engineers and all data scientists, AI engineers, etc., are using actually one platform, Databricks, to run all kinds of workloads and getting answers to the business questions in a very timely fashion. So yeah, that's how we have evolved the data platforms from one single server system, very slow, very limited, only on the structured data, to actually a full-fledged data lakehouse system. And most recently, in the last few years, what Databricks did was that they actually created another layer on top of their data lakehouse by the name of Unity Data Catalog, which means that they've brought in data governance on top of the entire data lakehouse as well, which means that they now have full control over who wants to see the data, who is allowed to see the data, where is the data moving, is my data well governed, I hope there are no any security issues, if there are any, can we manage those? All of these things are now being managed from data security and governance standpoint through the Unity Data Catalog, which Databricks had built. So I think all in all, today I wanted to actually convey to you students, professionals in data engineering space, I wanted them to understand, if they don't know already, by the way, that how these systems have evolved over the past couple of decades and where are we standing today. So I hope that video was useful for you. If you're watching this on LinkedIn, please do subscribe to my YouTube channel, or if you're already watching this on YouTube, then please subscribe and keep watching. I'll see you in the next video. Thank you very much. Allah Hafiz.